Thanks, everyone, for taking the time out of your busy day to spend a few minutes with me. I get a lot of questions about desktop virtualization, what it does, what it doesn't do, and often a question is asked, why isn't my organization using it if it's so wonderful? So the agenda for today's discussion will be, what is virtualization anyway? Point out the fact that virtualization is not something new that has shown up in the last 5 to 10 years. Point out that there are many layers of virtualization technology in use in almost every data center, and if an organization is using mainframes or mid-range systems, probably most of the virtualization technologies are in use. Then drop into what is desktop virtualization, and then discuss, if it's so wonderful, why hasn't it taken over the world? And then I'll give you some unasked for, shoot from the hip suggestions that may or may not fit your needs. So first, virtualization is the concept of taking advantage of excess processing, memory, storage, or other computer resource to create an artificial environment and then place that function into that artificial environment. The goal is to create an ideal environment for that function, which may look strikingly different than the actual physical environment in which that function is operating. Sounds pretty simple, but the effects in the environment are rather profound. Virtualization technology first appeared in mainframes in the 1960s. So if you talk with a mainframe-focused IT professional, they would point out to you that everything is virtualized and it's almost impossible to run something directly on the physical machine that is the mainframe. Also, single-vendor mid-range machines, these are machines that run Unix or some single-vendor operating system, usually from people like Hewlett-Packard, IBM, Sun, which is now part of Oracle, Fujitsu, Hitachi, and the list goes on and on. They introduced various types of virtualization technology into what they were doing in the 1970s and the 1980s. It started to appear on industry standard systems, that is x86-based systems, in the 1990s, so a relative newcomer. And with what is usually true in information technologies, people who have done it in the past, it's considered old and inadequate, and so newcomers don't pay any attention to them. The net result is the same problem that appeared and was solved in the 1960s and 70s on mainframes appeared and was solved on the mid-range systems in the 1970s and 80s, and the same problems show up on industry standard systems, and they're still working on solving them now. In the world of IT, we don't learn from the past. We run into it again and again. Now, the model of virtualization that the Kusnetzky group uses and I've been using as a touchstone for analyzing what different vendors are doing and what they are not doing has 7 different layers. I'm going to run through them very quickly, and you'll note that desktop virtualization only uses about 4 of them. There's access virtualization, that's at the top of the model, and the goal of that particular piece of technology is to hide from either side of the conversation what's on the other side. So, for example, a tablet or a smartphone may be communicating with a mainframe application. The tablet might be led to believe that it's talking to a website, and the mainframe application might be led to believe that it's talking to one of its own block mode or character cell terminals. There are a lot of wonderful things that can be done using that kind of trick. Application virtualization is placing applications into a virtual context that will allow them to run in environments that they're not normally supported. The example there might be to take a Windows XP application that would be incompatible on Windows 7 and put it in an environment that makes the application think it's running on Windows XP when it's really running on Windows 7. And Windows 7 thinks it's running a Windows 7 application. There are 2 different forms of application virtualization, one focused on clients that allows applications to run in an isolated environment or be packaged and delivered down to a client for execution there and then removed immediately, or it might stay there for a while depending on the settings the IT people set up before they sent things down, or have an application actually stream down to the client when a person clicks on an icon on the screen. Pieces of that application move over the network, start executing, and while the people are using the application, the rest of the application moves down the network to allow it to run. On the server, there are a different set of application virtualization features. The feature of allowing the application to run in an isolated environment so that it works even though it might be incompatible otherwise can be found in the server environment, but they have a couple of other wrinkles that are of interest to server environments. One of them is allowing multiple instances of the application to run on separate machines, either physical, virtual, or cloud, and then a workload manager intercepts requests for that application and sends them to the machine or to the instance in a virtual environment that has the most available resources, so you see high performance, scalability, and the like. Processing virtualization is 5 different types of things that create an environment for the whole operating system or the complete processing environment. It can result in high performance by splitting applications or data into multiple pieces and running them on separate machines, putting workload managers in front of processing resources so as requests come in at an operating system level, they can be distributed among many machines, failover, clustering to create a single computing environment, and of course the one most of us are aware of when we say the word virtualization today. There's virtual machine software that allows a complete environment, operating system, database, applications, and all to run inside of a capsule, and multiple capsules can run on the same physical piece of hardware. And then there's another type of function called operating system virtualization and partitioning, which does something similar, but what it does is make applications that were all designed to run on the same operating systems have an isolated environment. There's storage virtualization that allows systems to work with different types of storage without ever having any idea what kind of storage it is or where it is. And newer forms of this are actually doing quite a bit of optimization on the storage stream, removing duplicates, moving data from high-speed media to slower-speed media depending upon the actual requirements at the moment. They call this tiering. Network virtualization allows the network to look as a virtual resource. Systems that are allowed to communicate with each other can communicate without ever knowing there's anyone else on the network. And then, of course, if you look down the side, there is management for all of that and security for all of that. You can see it's quite a complex topic, and it's one that it's really easy if you read the material on the internet or read magazines for you to believe that it's virtual machine software is virtualization. That is because one particular vendor has done an excellent job of capturing a word that has been in use for 40 years and making that word its own. Now, if we look at desktop virtualization, it means different things to different suppliers, and this is part of the reason why people are very confused about this topic. From my vantage point, it's the use of one or more of the following technologies to allow an environment to work in a new and more efficient and manageable way. Access virtualization can be used to allow an application to run on a server somewhere in the data center and people attempting to use that application to run it using any device that is supported by the application virtualization technology. Citrix and Microsoft are well known for their products in this space. Citrix makes it possible for a Windows application, for example, to be viewed on a smartphone, a tablet, a desktop PC, a laptop, and several other types of devices that are not seen as often today. Application virtualization allows an application to appear to be running on the desktop when really it's running back in on a server somewhere, or it could have been streamed down to the desktop. Virtual machine software suppliers such as VMware, Citrix, Microsoft in a number of open source communities that are offering systems like KVM, which is kernel virtual machine, or Zen, which is another open source virtual machine project. They talk about encapsulating an entire client environment, and once it's in an encapsulated form, it can run in a number of places. Multiple of them could run on a desktop machine or laptop, so you could have Windows, Linux, and a Mac OS machine all running on the same machine at the same time. Or it could be running on a local server where maybe a work group is all running their applications on the same server. And then, of course, there are people who aren't using any of those virtualizations, but what they're doing is using a management technique to make it appear that the desktop is virtual. And depending upon the needs, different organizations might need different things, and a combination of these technologies might be put into use. The people who focus on just the management environment, and these are people like UC4, Unidesk, and a few other vendors, would point out that you really don't need virtual machine software. What people are really looking for is an environment that is secure and manageable and resilient. And what they mean by resilient, if an end user does something that destroys the environment, IT can put it back very quickly. And so productivity is heightened and costs are controlled. So depending on the goals, different technologies come to the forefront as what should be selected. Now, sometimes when I speak to Kusnetzky Group clients, the goal is the reduction of management costs. Because as we all know, PCs all over the organization need to be loaded, updates applied, new versions of applications, data needs to be placed there, things need to be backed up. It ends up being quite a costly affair. And there are companies, such as I mentioned earlier, that can take advantage of technology to make the standard desktop much more manageable and controllable. Other suppliers are saying, the best way to do that isn't to apply management technology by itself. Let's encapsulate the entire environment, put it in a virtual machine, and either run that virtual machine locally when that's the most appropriate choice. And that's usually the case when the person is highly mobile and needs to work inside of an aircraft, in a hotel, in an airport, or at the customer site. Or remotely when an individual largely sits in one place and just needs a highly reliable, highly manageable environment. And those vendors, of course, would present desktop virtualization as the use of virtual machines. The whole point for some people is to simplify adoption and integration of new devices and software. So, for example, if you're using the management tools, you might be able to set up a user's environment so that it's that particular person's applications, personalization, user data are all managed by the desktop virtualization management tool. Then it would be possible, if they lost their system or the system was destroyed, for a new system to be put on their desk, for the person to log in, and for that entire environment to be reconstructed on that new system. This has also been used to move people from Windows XP to Windows 7 or from different versions of Linux to another version of Linux. But depending upon the choice, different products and different technologies come to the forefront. Now, the good question that's asked all the time is, well, if this is so wonderful, why isn't everybody using it? And it's kind of an interesting aspect of human behavior is that we can use a technology and hate it, but we've learned how to use it, we've learned how to avoid problems, and it's become the devil we know. And there is a reluctance to let go of that, even if it's not a very useful environment. As long as the people get comfortable using it and cursing at it, usually they won't move. So there are many people who stay where they are, not because it's helpful, not because it allows them to be more efficient, but it's what they know and what they're used to. Another point that people bring up is that there's a rather large initial investment to create a virtualized desktop environment. And even though there may be cost savings in the long run in the 3 to 5 year period, the high initial investment inhibits people from taking that move. And if you think about, if we're talking about moving desktop virtual environments onto servers, we're in the process of exchanging low-cost environments for high-cost environments. If you look at memory that you would install on a desktop machine, that's more costly or less costly per megabyte than the same memory found in a server enclosure. The same is true of storage for a desktop machine versus storage for a server. So if you're moving all your desktops into the server environment, from at least the perspective of hardware investment and potentially software investment, you're moving from a low-cost environment to a high-cost environment. If you take a bigger picture and look at the costs of installation, management, operations, help desk, then maybe that large initial investment will be submerged in savings gotten elsewhere. People who are constantly being connected and disconnected from the network may find the idea of moving into a virtual environment not very pleasant, because if they're in the airplane, it may not be possible for them to get to their data or applications. This is where the people who would suggest using the management tool to create a virtual environment would point out that they have an advantage, because before that person would go on the trip, the management tool would put all of the necessary data and applications on their system before they left. Another really important thing that people do is they don't like change. IT people especially don't like change, because their job is to manage the environment and make sure things don't break. And anytime you introduce change, it's very likely something will break. And since it's their job to avoid things breaking, they try and get in the way of change. Also, we see people who are saying, I really don't want to work with a virtual desktop environment with Windows or Mac OS. I'm just going to use web-based applications with a tablet or a smartphone and just leapfrog over this new approach to desktop computing. But all of those have had a tendency to offer people reasons not to take the step and not to virtualize their environment. So my suggestions to you for your organization is to take some time and know what applications and workloads, which are usually made up of more than one application, are in the environment, who needs to use them, need to understand their needs for mobility, for training, what technology is needed to support their function, what kind of security is needed for the data and for that application, how should it all be managed. And when the entire portfolio is something that people know about, they can start to say, you know, these people sit at a desk in their office and need to access applications. Maybe access virtualization would give them enough of a virtualized environment with central management and control for their productivity to be maintained and the costs to be reduced. If someone needs the computational power of their own PC, then maybe either application virtualization or one of the forms of desktop virtualization that uses virtual machine software might be the best approach, because then the encapsulated environment can be moved down to their local PC and they have all the resources of a pretty powerful machine available to them. But I think it's really important to stop and take time to look before you leap. Many of the vendors in the virtual desktop arena would like you very much to be confused so that you'll select their product. And their product may be too costly, may not have the features you want, may not offer reliability or security that a particular application requires. I'm reminded of a quote from Lawrence Peter that says, if you don't know where you're going, you're likely to end up somewhere else. So I guess this is a time to turn to questions that have come in.
Yes, Dan, we actually have several questions that have come in. Let's take a look here. Are you able to see them, or would you like me to read them to you?
Why don't I go down the list and I can see them here.
Perfect.
And the question is, can you please tell me about some products that are available for server virtualization? Well, of course, this really isn't the focal point of this particular presentation, but I'd be glad to answer that question anyway. It depends on what you mean by server virtualization. If you're talking about mainframe server virtualization, it's built into the hardware and it is part of the operating system. You cannot run a mainframe in most environments without server virtualization being there. If you're talking about a mid-range system such as IBM's Power Architecture systems or Hewlett-Packard's Precision Architecture systems, which are in the process of being replaced by Itanium systems, once again, the virtualization technology is usually built into the operating system, and usually you are offered something like operating system virtualization and partitioning. They may call those partitions things like containers, jugs, LPARs. Different vendors call that kind of container different things. If by server virtualization you're thinking about how do I create a server image on an x86-based machine, there are 4 or 5 basic approaches. One is to use a product called ESX Server by VMware. And this is one of the longest lived of the x86 products and holds the lion's share of the market at this moment. And it allows multiple virtual machines to run on the same physical hardware. Then there are products from Citrix, which is called Zen Server. Citrix has productized the open source Zen product, which is built into most Linux offerings, and have made that available as a product that will run underneath Windows, Linux, and other kinds of x86 applications. Microsoft is offering something called Hyper-V, which is a product that Microsoft acquired like 4 or 5 years ago and has been building and improving ever since. There are several open source versions of virtual machines as well. Oracle is using a version of Zen, and they are calling that Oracle VM. There is another open source virtual machine software called KVM, which Red Hat and some of the other Linux distributions are starting to put forward. And since it's built right into the operating system, it is very efficient. We also have some other interesting technology. One is open source called VirtualBox. That was grown up in Sun's environment, but I believe Oracle has kind of put it off on its own. Which of these is the best choice really depends on what you're doing. It's difficult for me, without hearing more of the particulars of your particular environment, to recommend one over the other. And then the next question is, what are my thoughts on VDI? Well, VDI is virtual desktop infrastructure or virtual desktop interface. VDI means different things to different companies. But basically, VDI is a combination of access virtualization and virtual machine software. So a complete client environment is encapsulated in a machine, and it either runs locally, or it can run on a workgroup server, or back in the data center on a larger server, and individuals access that desktop environment using a number of different types of devices, and they are able to run their workloads back in the server. My thoughts are this is a really useful technology if people can overcome the initial cost of moving things from inexpensive desktop and laptop components to expensive server environments. But it has a lot of really powerful benefits because updates can be installed very quickly, problems can be addressed, centralized management, centralized security and control usually result in a reduced overall cost. The issues with this approach is that it doesn't work very well when you work in a disconnected environment. So unless you're willing to pay for the expensive Wi-Fi on aircraft or at hotels, you may find that you can no longer access your desktop environment. And so VDI has not taken over the world for the reasons that I mentioned earlier. But it is a useful technique if put in the right place. Next question is, I know I can benefit from desktop virtualization. Can you please suggest some ways for me to get started? I usually suggest to people that they first start by gaining a full understanding of what their people are doing with the desktop systems. Some applications don't lend themselves very well to being run in a virtualized environment. They are often technical workloads or workloads that require very large computational resources being available or require very high-speed graphics. Until very recently, virtual desktops environment didn't deal with that very well. And so those applications usually work better running on a physical machine rather than in a virtual machine. But once you have an understanding of the different needs of each environment, then it can become a step-by-step process to determine, do we want to give people access to that application that's running on a server someplace? Do we want to push that application down to them when they request it and then take it away from the machine later for security? Do we want to encapsulate a complete desktop environment and run it locally so that they can have multiple environments running side by side? You see this often in research and development. They will have a virtual machine for editing, a virtual machine for compilation, and a virtual machine that tests an equivalent of a production environment. And this allows developers to work with one system instead of having three on their desk. It's a longer discussion, but I think usually the first step is to know clearly and completely where you are today. Then plans can be made. Now, the next question is, the person would like to hear about VMware View VDI. And this is VMware's product that incorporates virtual access technology and points people to a desktop or client image running inside a VMware virtual machine. I know of a few companies using this. They usually tell me that they like the product. They think it performs very well. It appears to be very reliable. But when I ask them about do they have any complaints, the first thing that comes out of their mouth is that VMware is quite expensive, and they have to look very carefully at the entire environment for cost justification. So I guess my point would be it's a good product. It looks like it solves a lot of people's problems, but there are lower cost alternatives that do similar things. I believe that's all of the questions that are currently sitting in the list. Are there any other questions?
Let's take a look here. Actually, we do have a few more that came in, and there's still some time, Dan. If you could please click the refresh button, if you can see that right above. Did. Fantastic.
It's magic. Look at this. Now, what are the best practices for licensing Windows desktop guest OSs on various hosts? This is a very challenging question. It's a very simple question, but the answer unfolds into a very complicated answer because Microsoft has many different licensing and business terms and conditions depending upon who you are, what license you have with them, whether or not you have different service contracts. And so it's really hard to answer in a short period of time. But the overall point is that Microsoft has more or less been dragged into the virtualization environment because they'd really rather sell a license for each physical machine and manage it through client access licenses. And when they move things into a server environment, they want people to pay a client access license to use that, even if it's running in a server somewhere. So it's one of those things I hate to say it's an awfully good idea to talk to your Microsoft sales representative to get an idea of what are the best ways to move their products into virtual environments. Sorry, I know I kind of chickened out on you there, but it's a really complex answer. If you're running Windows XP, Vista, or 7 via Microsoft Virtual PC and do a system image backup via USB to an external drive, can you load the backup to an actual hardware or real hardware? I'm sorry to say I don't have personal experience with that combination of things, and so I'd have to do some exploration on what the limits of that technology are. And so it's a good question, but unfortunately I'm not the right person to answer it for you. The next question is, are open source alternatives available for envisioned or application streaming? That is, alternatives to Citrix, XenDesktop, ICA, and VMware View. I will have to think about that for a moment. It seems to me that there have been a number of approaches for application streaming that were part of the open source terminal server project. And I'm sorry I cannot remember the name of the project, but I remember reading about it. So I'm not going to be of much help there either. So I think that I've stumbled my way through all of the questions at this point. Okay, there's a couple more questions have appeared. The same person that asked about the Microsoft licensing came back and says, is there a minimum number of PCs which virtualization becomes practical for management and maintenance? And that's, again, a very simple question that unfolds into a very complex answer, because it really depends upon what you are hoping to accomplish through this configuration. I have seen environments where as few as 5 systems have been used, where what they are using is access virtualization to get to applications running on a server. And this allowed a small company to reduce the number of PCs needed in the environment that required management. And what they did was buy a desktop or thin client hardware from companies like Wise, Hewlett-Packard, IBM, and the like. And that allowed them to put systems in a doctor's clinic where there was no chance of someone getting to that device and getting data out of it so that they could comply with the HIPAA regulations. And I've also seen environments where very large call centers have used the same kind of technology. So it's really a justification on a case-by-case basis rather than a, if you're doing 5 or 10, you need to do this. If you're doing 20, you need to do that. Next question is, what does VDI scale and how quickly does the physical network infrastructure saturate? I love these simple questions that unfold to a big, complicated answer, but this is another one. The first question that one would have to ask is how much bandwidth is available in the infrastructure of that particular company at that particular location. If a company is already fully utilizing the bandwidth that is available on that network, adding VDI may not be acceptable in certain locations and work perfectly well in other locations. So once again, this is a kind of question where a consultant would need to go examine the environment, learn what the network was being used for at the moment, what workloads was it supporting, what excess bandwidth was available, and then it would be possible to consider if we add VDI in that environment, what would it do? So there aren't simple answers to those questions. In almost every case, it's necessary to go look at the environment, determine what is there, determine the current workload, and see whether or not the environment can support the number of VDI sessions that the particular use case requires. I have seen environments where there are thousands of desktop environments being supported over the network, but that is one of the important considerations. Another very important consideration is the storage performance in this environment. Since this is a very different environment and the use of storage is very different than each individual using his or her own storage inside of his or her own PC, you can see some very difficult behavior. For example, if everybody comes in between 7 and 8 o'clock in the morning and turns on their system, you could imagine the storage subsystem is getting a firestorm of usage suddenly appearing and overwhelming it. This is a difficult thing to deal with. So it's really important to plan before jumping into this. That's the reason why some organizations choose different approaches than VDI, because VDI, while appearing to be a really nice solution to a lot of problems, sometimes creates its own problems. And maybe it would be better to use some form of application streaming, or possibly what was really desired in the first place was a well-managed environment where an individual's data, applications, user personalizations are all preserved across the life of specific systems and can be reproduced reliably somewhere else when it's time for them to replace a broken machine or move to a new machine. Now here is a question that has come up that in the long term, does Microsoft have a chance to challenge VMware? This is a really interesting question for me because both of them are clients and have been people I've advised in years past. Microsoft always has a chance because it has such a huge installed base, and a lot of Microsoft's overall strategy has been to move new functions into the environment and charge only a marginal price for that new function. They've done this with Windows for decades. Just ask anybody who had a TCP/IP package and was selling that for Windows 3.1 when Windows 95 came out and it had a TCP/IP package already built in. Their sales plummeted because people already had something that was good enough. Now, the truth is some of those independent TCP/IP packages perform better, more reliable, but in many cases people say good enough is good enough, and if Microsoft is giving me something that's good enough, I will use it. And that, I think, is the mindset that will prevail for some users of Microsoft's Hyper-V. You could make the strong case that VMware's products are stronger, more scalable, perform better in a lot of circumstances, but Microsoft will still win some business because people will say, I already have an agreement with Microsoft. This fits under the agreement, so the cost per system for Hyper-V is very much lower than the cost for VMware would be, so we will use it. Does Microsoft has an opportunity to convert some VMware environments? I think it's certainly the case if VMware continues to change its pricing strategy and cause people to have concerns about what the actual costs will be, or limiting how people can use their systems based upon terms and conditions rather than what the physical machines are capable of doing. But it is an interesting race to watch. I've done a lot of survey work in the fairly recent past for a client on the impact of VMware's changes in its pricing and its terms and conditions and how they're approaching the market. And it did appear that at least in a certain percentage, and I'm sorry, I'm not at liberty to divulge what that percentage is because it was a private study for a client, but a certain number of people feel like they're going to more closely examine Microsoft's approach because they find VMware to be too expensive. It was also interesting in that same study, KVM from Red Hat and other open source suppliers has had an uptick in interest for the same reason. But those are all largely server virtualization questions. There is a question that is asking, a very technical question, can you use PXE or Pixie Boot to boot a virtual desktop? And I have seen that done when the virtual desktops were running Linux and people were using either Xen or KVM. I don't have the technical details of how it was done. I just observed it being done. Let me see if I can read through these other questions. Next question is, how well does VDI scale and how quickly does the physical network infrastructure saturate? That goes back again to what physical infrastructure are we looking at? There are some physical infrastructures in some organizations that have a great deal of room overhead available for VDI to scale, and there are other more established companies that have much more limited network bandwidth available. And that really depends on the environment and how they're using it. Now, someone is asking, this is how my company allows me to access my system from the home or road. Is there a better way? Now, my question would be to that person, are they accessing the system using VDI, where the server is running a copy of the desktop image, and that image is being projected through the network to the desktop or laptop or mobile device through an access virtualization? And if that is the approach, it may be better to use an application virtualization strategy where the applications are actually moved down to the remote device, and then when the person starts the machine at home or on the road, they're running a local copy of the application. That often performs better, and that can be done with the same levels of security and control. The only challenge to that, of course, is the data needs to move down to the PC. And some regulated environments, it is not wise for the data to leave the data center. And so they may be using VDI as the approach, not because it performs the best, but because it allows the data to be kept in an isolated and controlled environment. And I think I've addressed all of the questions.